Okay, lesson 5.5, the use and misuse of statistics. A valid conclusion is one that's supported by unbiased data that has been interpreted appropriately. When you read a conclusion someone has made based on statistics, you must decide whether the conclusion is valid or not. To do this, you should ask yourself a couple things. Is there bias in the way the data was collected? Was there bias in the way the sample was selected? Was it random? The questions were phrased? Were they leading or loaded? Or the way the survey was conducted? Was it anonymous and written, or was it verbal? If the data involved measurements, were they done accurately? And are there any graphs? And are they drawn accurately, or do they mislead the viewer? Well, the first two lessons were about basically the first section here. We don't really talk about measurement, but we are going to discuss graphs and how they can be misleading. So let's take a look at a pair of graphs that represent the same data. Canada's population by age according to the 2001 census. So we have a 3D pie graph, and we have a topical 2D pie graph. When you're comparing graphs, you want the topical 2D pie graph. This is the unbiased pie graph because you get exactly the way the data is intended to be represented. The way a pie graph works is this slice of the pie represents 24% of the entire pie. However, when you take that pie and you slant it on its side, this piece right here is significantly bigger than 24% of that oval. It's more like a third. So we don't want to use 3D graphs. They distort the view. Some parts of the pie. For example, the back, too small, the front, too large. Oh. Line graph. A company's profits over a 5-year period. So here we have 2003 to 2007. We have our annual profits in millions starting just over 4, and we're going up to just over 5.5 and then back down to 5. Whereas this graph looks like we had a more significant gain in the first few years and then a very low drop there. So which graph is better in this case? Well, this graph shows an omission. This graph starts at 4 and doesn't show an omission. So the second graph makes it look like the company's profits went significantly more up, whereas this one showed less. Now the advantage to this graph is it's spread out so it covers most of the graph surface. If you're creating a broken line graph or a line graph, you want to show your omission, but still spread out the data as much as possible. So what would be better would actually be a combination of these two graphs, showing our omission and starting at 4. Four grade 9 students collected data on school lunch preferences. Is their conclusion valid? Let's assess the validity and ask ourselves a couple questions. Well, favorite lunch meals, frequency of response. There's the options: pepperoni, vegetarian, burgers and fries, macaroni and cheese, salads, sandwiches. Conclusion. We asked students to tell us our favorite lunch meals and displayed the results in a bar graph. We concluded that the school's cafeteria should serve more pizza since it is clearly the favorite lunch of students. Was the sample size appropriate? Well, this was at our school, so let's take a look at sample size. We had, if we count the tops of the bars, and I've kind of already done this, we had 50 people. And our school has approximately 450 students. So we had 50 out of 450. 50 out of 450 is greater than 10%. 50 out of 500 would be 10%. Therefore, it's appropriate. We have a good sample size. Was the sample representative? We asked students to tell us their favorite lunch meals, and it does not say how they collected the data. So for it to be representative, we would want random, but it's unknown. Was the survey question biased? Well, it says we asked students. That implies that they asked them verbally. It doesn't actually say, but let's assume. It was not anonymous. So there's possible response bias. How was the survey conducted? Well, it said they asked grade 9s in person to tell them. Not great. Also, if you're going to ask people in the school, grade 9s may... Oh, actually, it was just for grade 9 surveying. It doesn't say they asked grade 9s. My bad. But they were asked in person to tell them. That's not great. That's probably not anonymous. Is the graph constructed accurately? Well, we have a problem with that too. No, because it's 3D. We don't want 3D. It makes bars look bigger. Or smaller. Also, if we look at the scale, look where we start. 4. So while this doesn't look like many responses, this bar actually represents 5 people. So the scale. The break isn't shown. A lot of issues with this graph. Let's look at one last example and analyze cause and effect. A group of grade 12 students performed a linear regression. You've done one of those. On data they collected from Statistics Canada about the number of seniors and the number of weapons crimes in Canada. Is their conclusion valid? To assess the validity of conclusions, ask yourself these questions. Was there bias in the data collection? Is the graph constructed accurately? Is the correlation strong? Does the analysis support a cause and effect relationship? Well, what do we have here? We have 1, 2, 3, 4, 5 dots on the graph. 5 years. 2000, 2001, 2002, 2003, 2004. Number of persons charged with weapons offenses and the number of seniors over 65 with income. There is a strong positive correlation between the two variables. As the number of seniors increases, weapons charges increase. Therefore, criminals in Canada are becoming older because of our aging population. Well, they are right. There is a strong positive correlation, as shown by that R squared value, which you found in previous units. But But was there bias in the data collection? It says they collected data from Statistics Canada, so no. Stats Canada is reliable. Is the graph constructed accurately? Well, we didn't show any omissions, but the data is spread out, so that's not bad, but we should show the omissions. Now the thing is, when you create a graph on Google Sheets or Excel, you can't actually show breaks. So it's not your fault if in your assignment you didn't show your break. Is the correlation strong? Yes, yes it is. The R-squared value, very close to 1. Does that mean this is a cause and effect relationship? It does not mean it's a cause and effect relationship. Just because you have 5 points that follow a line very closely, you may need to look at more data, but in this specific example, this is more a case of common cause. If you pick things that have a common cause, you're likely to get a strong relationship, but it does not necessarily mean cause and effect. So be careful. I think a really good example of Unit 4 assignment that I got in a previous year was someone looked at comparing goals and points. No, it was wins and points of NHL hockey teams. The statement was, do teams that win more games earn more points in the standings? And they did a correlation. And the thing is, well, yeah, if you win more games, your team has more points. But the common cause is that points are dictated by wins and overtime losses. But wins and teams that win more generally have more points. So there's a common cause there. And it's just as wins go up, points go up. They are directly related. It doesn't mean that they are cause and effect. So what's the common cause here? Well, as population goes up, there's more old people. As population goes up, there's more weapons crimes. That does not mean seniors cause weapons crimes. Okay, that's it for lesson 5.5, and I'll see you in our last, well, there's 2 more lessons, but the next one's really the last me lesson. The last lesson of the unit 5.7 is more of a you lesson. But thanks for watching, and I'll see you next time.